So there are 5 different types of reactions that we're going to look at in this class. And the first one is synthesis reactions. So what happens in a synthesis reaction is that you have 2 different reactants, let's call them A and B, and they're going to combine together to form one single product, AB. Okay? So in a synthesis reaction, let's look at an example to see what exactly is going on. So this tells me sodium reacts with oxygen. So those are 2 individual elements that are going to react together to form one product. So sodium has the symbol Na, and it's going to react with oxygen. Now the thing you have to be careful about is the fact that oxygen is diatomic. It's one of your 7 diatomic elements, so when it's by itself, like right now, when it's by itself, it cannot exist as O, it has to exist as O2. Okay? So these guys are going to combine together, sodium and oxygen are going to combine together to form one compound. Well, if I take a metal and combine it with a non-metal, that's going to form an ionic compound. So to create the formula for this ionic compound, I need to cross charges. So sodium has a +1 charge, oxygen has a -2 charge, so the formula for this would be Na2O. And that's all there is to a synthesis reaction. Now the only thing that's left for me to do is to balance this. Well, I have 2 oxygens on my reactant side, which means I need 2 oxygens on my product side, so I'm going to put a 2 right there. Now I have 4 sodiums on my product side, so I'm going to put a 4 in front of sodium, and I'm done. So that's the first type of reaction, synthesis. Decomposition reactions are the exact opposite. So you have one reactant that splits apart into 2 individual products. So let's look at an example. I have hydrochloric acid. So I start off with HCl. Okay? Notice the 2 components of that decomposition reaction are going to be hydrogen and chlorine. Both hydrogen and chlorine, however, are diatomic. So instead of just having your products be H plus Cl, you're going to have H2 plus Cl2. And then the only thing I have to do is balance. So I'm going to put a 2 in front of HCl, and I'm done. The third type of reaction is a single replacement reaction. So what happens in a single replacement reaction is you have one element that's by itself, and then a compound. Now that one element's going to go in, and it's going to kick out one of the original elements in the compound. So now B is by itself, and A joined to form a compound with C. Okay? So let's look at this example. Magnesium reacts with sodium nitrate. So magnesium is what you start with. Sodium nitrate, to write this formula, sodium has a +1 charge, nitrate has a -1 charge. So the formula is going to be NaNO3. Magnesium is going to go in, and positively charged metals, so metals that when they form an ion are positively charged, well that's all metals, but atoms that form a positive charge, they're going to kick out other positively charged ions. So magnesium is going to kick out sodium specifically because when they are ions, they are both positively charged. So magnesium kicks out sodium to form a new compound, so magnesium is going to form a compound with nitrate. Okay, so to write that, I know that magnesium has a 2+ charge, nitrate has a -1 charge, so magnesium is going to form a compound with NO3, and now sodium is by itself, so I've got a balance. Now notice I have 2 nitrates on my product side, so I've got to put a 2 in front of sodium nitrate, which means I now have 2 sodiums, so I'm going to put a 2 in front of sodium. Okay, so in single replacement, you've got one element that's kicking out another one that was part of a compound. In double replacement, you have a complete and total switch of partners. So A was with B, and C was with D. Now A is with D, and B is with C. Notice here that your outside elements, so A and D combine together, and your inside elements combine together, so C and B. So I call this innies and outies. So my innies are my B and my C, my outies are my A and my D. So they completely switch partners. So here I've got potassium oxide reacting with lead nitrate. So potassium oxide would be, potassium has a +1 charge, oxygen has a -2 charge, so K2O, plus lead nitrate, well lead has a +4 charge, nitrate has a -1 charge, so that would be PbNO3,4. Now that's going to produce, I'm going to do innies and outies. So my outies are potassium and nitrate. So potassium, I've got to form a brand new compound now. Potassium has a +1 charge. Nitrate has a -1 charge. So that's going to form KNO3. Lead and oxygen are going to form a compound. So lead has a +4 charge. Oxygen has a -2 charge. So when you cross your charges and then simplify, that's going to make PbO2. Notice your metal always goes first, followed by your non-metal. So that's what can help you to determine which element needs to go first in the compound. Now the last thing I need to do is balance. Well, I've got 4 NO3s on my reactant side. So I've got to put a 4 in front of KNO3. Now I have 4 potassiums, which means I need to put a 2 in front of potassium oxide. And now I'm actually balanced. The last type of reaction is a combustion reaction. So in a combustion reaction, you have what we call a hydrocarbon, so a compound that has hydrogen and carbon in it. It reacts with oxygen always, and it produces carbon dioxide and water. Okay? So for example, when you light your Bunsen burner, what you're doing, the gas itself, that is your hydrocarbon. It reacts with the oxygen that's in the air, and so what's going to be produced is carbon dioxide and water. And notice the other product is energy. Think about the Bunsen burner. That's got lots of energy that it's releasing. So all of that, the Bunsen burner is a combustion reaction. And there are a lot of different combustion reactions that happen. But the main thing for you to know is that your reactants are always the same. Just your hydrocarbon might change, but you always have oxygen. And then your products are always the same, carbon dioxide and water. So let's look at an example. I've got methane, which is CH4. So CH4 is going to react with oxygen, and it's going to form carbon dioxide and water. Now, the hardest thing for combustion reactions is actually the balancing. So I always balance carbons, then hydrogens, then oxygens. I go in order. Okay? So here I've got 1 carbon on my reactant side, 1 carbon on my product side, so I'm fine there. Now I'm going to look at hydrogens. I've got 4 hydrogens on my reactant side and 2 hydrogens on my product side, so I've got to put a 2 in front of water. Then, if you look at my product side, I've got 2 oxygens from carbon dioxide, and I've got 2 oxygens from water, which means I have a total of 4. So to make 4 oxygens on my reactant side, I have to put a 2 in front of oxygen. And those are all the 5 different types of reactions that we are going to be looking at.